True. Starting strong with someone who is an inspiration for many in the field, in the field of cybersecurity and STEAM leadership. Our first speaker is Barsha Karki, the Solution Engineering Manager for A&G at CyberArk. With nearly 15 years of experience across cybersecurity, data management, and telecommunication networks. Beyond her impressive technical background, Barsha is also a passionate advocate for women in STEAM. Today, Barsha will share her expertise on implementing zero trust and identity-driven security, helping us to understand how to design secure and scalable architecture in today's complex digital world. So please join me giving a warm welcome to Barsha Karki. The stage is yours.
I'll take this up. Good morning, everyone. Hello. Okay, let me just sort out the tech first. Okay, good. Good morning. Great to be here. Thank you, Shito, for that wonderful introduction. So today, I'm going to talk about zero trust with identity as the new perimeter. Has everybody heard of zero trust? Who's heard of zero trust? Great. And have we heard about how identity can kind of add into that zero trust architecture? Cool. Well, we'll learn a little bit about that. Yes. Awesome. Yes, please. And this is what I click. Okay. Nope. Doesn't matter. So, agenda for today, I've got about 30 to 40 minutes, and we can have Q&A in the end, or I'm happy to take questions as we go. Let's make it interactive. That is my LinkedIn. Thank you for connecting. And just to motivate a little bit, I've got a couple of giveaways for good questions, right? This one here, I've been told, I know we're in the world of agentic AI, but I actually went to a shop and I asked a person helping there to say, hey, what would developers like? This is something that I haven't tried yet, and he said developers really like that. So whoever wins it, I'll get your feedback, please, and I might get into that as well. Disclaimer: you'd have to be legal drinking age. So let me know if you're not, okay? And the next one is pretty tamed. It's chocolates, all right? So I'll do a quick intro of myself. I'm Barsha Karki. We'll talk about what zero trust is, why zero trust, why now, what does identity as the new perimeter in zero trust architecture means, and should developers actually care about zero trust? Right, and then I've marked Q&A in the end, but I'm happy to take questions as we go. All right. So a little bit about myself. I'm a network engineer at heart. I've been in Australia. It will be 20 years next year. I'm originally from Nepal. My first role was a network engineer at Alcatel-Lucent. Alcatel-Lucent doesn't exist anymore. It's part of Nokia, and that was my first graduate role. After that, I went into solutions engineering roles. So I joined Equinix data center. I was there for around 2 years as a solutions engineer. Then pivoted a little bit into security. So I went to Checkpoint, and security at the time was network engineers managing firewalls, right? So I spent just a year at Checkpoint, which was the shortest stint I've ever had. And then I went up the stack from layer 3 to layer 7 in Akamai Technologies, worked with web application firewalls, content delivery network, around there for 3 years as well. And then I pivoted slightly still to storage with NetApp. I was there for about 3 years as well, still in solutions engineering role, and became a team lead. And then went to Zscaler. In fact, I presented in this event last year when I was in Zscaler. So, navigated into the field of zero trust. So how has networking evolved from traditional hardware perimeter-based to how everything is everywhere and how you connect. So and because of my experience with that, I actually spoke about Zero Trust last year a couple of times. And now I'll be completing 6 months as a solutions engineering manager at CyberArk. So I manage a team of ANZ solutions engineers. And yeah, we look after all the top customers in Australia, all the banks, insurance companies, mines and stuff. So that's what I do. Been here for about 6 months. So that's been my journey. I just wanted to introduce a little bit about that because I think, from the networking to security to layer 7 to zero trust and then identity, and I've seen that, evolution in my own journey to understand how different technologies fit in, and it kind of, makes the puzzle complete. Right? It has for me. So I wanted to share that with you today. So to the conversation today, what's zero trust? Does anybody want to have a go around what zero trust is? Yeah, great.
Yeah, I mean, if someone's in the system, they can't attack basically.
Yep.
I'd love to.
Yep.
So if they have access to the platform it's running, there's still barriers, they can't see everything.
Yes, absolutely. So it's limited. Even if there's somebody's in the network, they might not have as much privileged access or just enough as they're meant to be. So great answer. And no trust, yes. Nobody should be trusted. I love that answer. Yes, because traditionally, me being a network engineer, you kind of go, anybody who's connected to network is trusted. And then you ask for password, then you verify. Whereas now, we've gone from that, trust but verify, to never trust and always verify. And continuously verify, right? So I'll talk a little bit about that. Has anybody heard about Operation Aurora? No? I've got a video to share.
In 2009, Google found out, and cybersecurity was never the same again. In the world of cybercrime, few incidents...
Sorry, I'll just start from the beginning, if that's okay.
What happens when a country attacks a company? In 2009, Google found out, and cybersecurity was never the same again. In the world of cybercrime, few incidents have had as much impact as Operation Aurora. This was a series of cyber attacks that targeted some of the biggest tech companies in the world, including Google. In this video, we'll delve into the story of Operation Aurora, discussing who was behind it, what their motives were, and what the fallout was. In the quiet of the night back in 2009, a group of hackers, later known as the Aurora Group, were preparing to launch one of the most significant cyber attacks in history. The target, Google, one of the most powerful tech companies on the planet. The hackers, believed to be based in China, had spent months developing a sophisticated piece of malware. This malware was designed to exploit a vulnerability in Internet Explorer, a widely used web browser at the time. The hackers' goal was to gain access to Google's internal systems and steal valuable intellectual property. The attack began with a simple phishing email. This email, disguised as a message from a trusted source, was sent to a Google employee. Attached to the email was a document, seemingly harmless but infected with the Aurora malware. The unsuspecting employee opened the document, unknowingly triggering the malware. The hackers had now gained a foothold in Google's systems. They could watch, wait, and plan their next move. Over the following weeks, the hackers moved laterally through Google's network, gaining access to more and more systems. They were like digital ghosts, leaving no trace of their presence. Their ultimate goal was to access Google's source code repositories, the digital vaults where Google's most valuable intellectual property was stored. And they were successful. The hackers managed to steal unknown quantities of source code, a significant blow to Google. But the hackers didn't stop there. They also targeted other major tech companies, including Adobe and Juniper Networks. In total, over 30 companies were hit by the Aurora attacks. The fallout from Operation Aurora was significant. Google publicly disclosed the attack, a rare move for a company that had been the victim of a cyber attack. This led to increased tensions between the US and China, with Google even threatening to pull out of the Chinese market. The tech industry also took notice. Companies began to invest more heavily in cybersecurity, realizing that they could be the next target. The era of innocence was over. The era of cyber warfare had begun. Operation Aurora was a wake-up call for the tech industry. It showed that no company, no matter how big or powerful, was immune from cyber attacks. It was a stark reminder of the importance of cybersecurity, a lesson that remains relevant to this day. If you enjoyed this video, please leave a like and subscribe. Also,
Yeah, so, we are at Google DevFest, right? So I thought this was really relevant to share because Google's has had a massive role to play in creation of the Zero Trust framework, right? After Operation Aurora, it wasn't just Google, it was Akamai, it was quite a lot of large global companies that was attacked by this group called the, it was in China, Elderwood something. And since then, I think Google's actually created a series, like 4-episode series or something, on the ins and out of the operation as well. So you could Google it, or you could go to YouTube as well and find it, pun intended, unintentionally. But yeah, so I thought I'll kick it off with this because it kind of sets the scene. I think we heard a couple of things, right? We heard phishing, we heard accessing a lot of codes. We heard vaulting, and as developers, all of those things are really important. Like, we store secrets. Where do we store them? If you've got secrets, are they hard-coded? And if they are, how easy it is for somebody who gets into the network to extract them? And that's part of cybersecurity, and that's the developer mindset, right? Because developers went from developers to DevSec and now DevSecOps, right? And that's all part of building security, but now also keeping operations in mind as well, right? Any questions or comment so far? No? Cool. So a little bit more on Zero Trust. Zero Trust was coined in 1994. There's a little bit of word. It's from Wikipedia, but just a little bit of background. But in 2009, Google implemented a Zero Trust architecture framework called Beyond Corp. And that was in response to Operation Aurora, right? And Beyond Corp is not just a framework anymore, it's actually a product suite. And there's a lot of competition, and when I was in Zscaler, we competed with Beyond Corp, right? And so in 2010, the Forrester analyst John Kinderberg kind of, made a lot more. He termed the Zero Trust model and created a lot of controls around it. So you can find a lot more around what that means. What do you need to do to stick to that framework? And in the last 15 to 20 years, I think mostly driven by COVID, right? When people are not connecting just to LAN network, not going into the office, but they're everywhere. And during COVID, people were everywhere, but now we know with the cloud transformation journey, organizations don't just have their own data center either, right? You're using a multiple cloud environment, and not just IaaS and PaaS, SaaS. How do you make sure the same level of control you had in hardware, firewalls, you extend that to the same level in all the cloud environments and all the BYOD devices as well? There's a lot to consider, right? So why Zero Trust and why now? And that was a bit of background on what Zero Trust is, why Zero Trust and why now. So to explain that, let's look at how attackers would attack in a traditional network. All attackers are trying to do, and we saw it in that example, very similar. What they do is they find you, they compromise you, they move laterally, and then they steal your data, right? So in that example video that we saw, somebody got a phishing email. They clicked on the link, got the malware, and then that malware is talking to command and control center, right? So they found you and they compromised you. Now they were then going to access a lot more code bases, So they're moving laterally. And in the developers world, it is going from a user access to an elevated access, admin access. Because when you get to the admin access level, you can cause a lot more harm. You can cause harm, but at the end of the day, your data is your crown jewel, right? Any organization, universities, research data, medical, medical companies, banks, our data, and how many, incidences have we heard lately, and how many, like I've at least got 3 emails in the last 2 weeks saying your data has been compromised, your driver's license gone, but I'm not going to change my driver's license, but there's layered approach to protecting yourself, right? So this is how attackers attack in traditional network, and it's easier in traditional network because it's easy to find you. You've got public IP addresses, and whatever is public, whatever can be seen can be attacked. So, in the zero trust model, you hide the public addresses. It's not outside in connection, it will be inside out. So you allow connection for only people or identities that need that access. It's not like anybody can come in, knock on the door, and you let in. You open the door and then you invite them in, right? So that's how the model's changed, and that's the thinking with zero trust. So zero trust core principles are, a few of us said, never trust, always verify. Least privileged access. Whoever gets access to whatever they need at that point in time. In developers world, we heard just in time. We know just in time access. There's zero standing access as well. I work for CyberArk. If you're a developer, you log into your AWS console, you may have access to so many different environments. Imagine if only for an hour a day or Friday or whatever, you can actually see everything. Everything else is invisible the rest of the time. Right? So just like those public IP addresses, your environments, it's just in time, but it's also you can only access it, and you're only allowed for, outside of that allowed time, you cannot even see anything when you log into the portal. Right? And that's the level of security you want to add to developers as well. Because if your account is compromised, if your credentials are hacked, then somebody else can get a lot more access and can create a lot more havoc, right? So why now? We talked about, especially after COVID, we've got a lot more hybrid remote working environment, right? So in traditional network world, we talk about castle and moat. People had their network, they had control, they had hardware, whereas now you don't have that. There's, it's the idea of fading fortress. There is no fortress because people are everywhere and your crown jewels are everywhere, right? So cloud native SaaS and APIs create borderless environments. The keynote, I was really, that was really engaging, the keynote, right? We talk about APIs, the MCPs now. And agentic AIs, right? So there's the access, Ankur showed how he could create a tool and he could have an agentic AI use different sort of tools. What if one of those tools were your bank account because you're trying to bid on a house or you're trying to buy some clothes and you want to buy it at the lowest price possible? There's so many use cases for that, right? So APIs are creating borderless environments, and breaches increasingly target identity, which in our case is admins, right? Even with phishing, there's general phishing, there's spearheading. You're targeting the CEOs because the higher up you go, the more confidential information you can get, right? So that's why zero trust. Never trust, always verify, and continuously monitor, right? Any questions so far? Okay, so with that, and that was my from my experience when I was at Zscaler, right? So now identity, and at Zscaler we talked about how employees can have access to your internal resources. How do you manage that? But also, if your employees are going into the it's almost like virtual firewall, right? Rules. Where are they going? Are they trying to connect to a malware site, command and control? How do you intercept that? And in all of that, we worked on this side, whereas the first part that we verify was identity. As soon as somebody logs in, we verify the identity, we validate it, and then we apply the policies, right? So today I'm at a company where I work for an identity, security company, so that kind of ties really well, because identity is the new perimeter. Your perimeter is not your network anymore. Wherever your identity is, that is your perimeter, right? You got to apply the right level of policy at that level. So, this is, this could be you, this could be me. How many logos do we know and how many logos do we use on an everyday basis, right? So this is, like web app, SaaS, applications, and those applications could be personal, like Google Drive is personal, OneDrive can be personal, and then public cloud, it could be an organizational Google Cloud, Microsoft Cloud as well, and then you've got the remote workers, hybrid, branch. But, what's stopping from somebody accessing your personal drive, Google Drive, or accessing your corporate Google Drive and trying to copy from your corporate account to your personal? In fact, that was one of the incidences we heard a few weeks ago where an employee, this was in an insurance not too far from home, close to home, where an employee actually saved his passwords on his personal Google, browser. And so when somebody attacked, a hacker got into his laptop, he got the credentials from his personal drive to then use for his corporate. And that's how a lot of the data and our credentials were hacked in that, right? So there's quite a lot of things we use, we don't think, but hackers are also thinking, right? And they're trying to find the loopholes. So, one way to do that, and these are a couple of slides that I used from Zscaler. So when a user tries to connect to any of the corporate environments, you have a zero trust platform who actually looks at logging in, validates it, applies the right policy at the right time. And if you're going to any of your infrastructure, it's an inside-out connection, not outside-in, right? Any questions, comments? Okay. So I guess identity as a new perimeter, what does it mean? Every user, every device and API needs identity. And, every user could be human. It's not just humans anymore. It's machines. It's always been machines as well, right? We talk about service identities, IoT, OT. But now it's not just even that. It's agentic AI, right? So every device, every user, whether human, non-human, needs identity. Network location by default does not mean trust. And, we'll need a strong identity service combined with MFA and continuous monitoring and validation to create that new perimeter, because it's not a firm hardware perimeter anymore, right?
So like everyone's working in the coffee shop. Right?
Yeah, exactly, at the beach, and you're actually using public Wi-Fi. Number of times organizations go, don't use public Wi-Fi, but sometimes they have to.
Or even like WeWork.
Yes.
At your office, you're still sort of in a coffee
That's right, yeah. And if WeWork's network is compromised, a lot of people, unless you've got your own sort of security, for your employees. And even with cloud, right, Google, Amazon, Microsoft, they all provide a level of security, but security is such a layered approach. There's no silver bullet. And when you use public cloud infrastructure, it's a shared responsibility. Security is shared responsibility, all right? Okay, why should developers care about zero trust? Why do you think?
Because once they develop the code, what can happen, there can be a backdoor left when developing the code, so that then the original, the code can be accessed by someone
Yeah.
this backdoor in order to then compromise the entire environment where this code was rolled out?
Absolutely. Great answer. Yeah, because everything runs on code, right?
They have a lot of credentials as well.
Say that again.
They have a lot of credentials as well.
Credentials, yes. Yes. Yep, absolutely. Yeah, I mean, developers manage all of that, right? And you'll save it somewhere, and if you got access through that, that's game over, right? Yeah, great answers. And you know, like I said, perimeters are gone. So identity is the new perimeter. Apps and APIs are now the front line of defense, right? The coding. And also, developers decide who and what gets access. The codes, the backdoor, you know, who and what gets access at what point. So, on a slightly different note, we're talking about zero trust, and this generally applies to internal people, right? But there's SSH keys, right? All machines have SSH keys, and there's no way to actually discover how many SSH keys are active, and how do you manage them? Do you need to rotate them? How long have they been active for, right? In CyberArk, we've been talking to customers to help with that. But also, I don't know if you, and it's slightly pivoting, but for developers managing web-facing applications or public-facing websites, you know, certificates, TLS certificates are now going from 1 year to 47 days by 2029. It's already down to 200-something days, right? And that's a lot of management to do. And you've got to have automation, which means you then have to have added level of security to make sure everything's working fine, right? So pillars of zero trust, you know, this is from National Institute of Standard Technology. These are the 5 pillars of zero trust. Where do you think developers would fit in? There's identity, devices, network environment, application workload, data. That's it, yes. Absolutely. Like you go through all of it, right? Like confidentiality, integrity, availability, and you know, data is the most important. Identity comes at the first, but then you're working through the devices, you're creating your environments, networks, making sure it's connected to the networks, you know, you've got access to all of that, and application workload is our bread and butter, right? So and that's why I think developers have to think about that zero trust model when you're working. So, you know, just the last 5 minutes? Oh, great. So, I guess from a developer's point of view, I think protecting privileged accesses, right? I was in Melbourne earlier in the week, and I was talking to some of my team and the wider team, and we were talking about some of the customers that we go and meet and talk and help. One of the customers in the medical industry, they actually know that some of the machines have been compromised. Right? It's interesting because you've got older equipments, they need software patches, they need upgrade, and it's like you have to assume there's already a breach, right? Because you can't keep up with a lot of things that goes on. So protecting privileged access is the first thing, right? Because even if somebody's in there, how are you protecting or preventing lateral movement? If it's contained in that, you're better off. Even that machine might be compromised, right? Sometimes it's looking at the risk versus reward. So you're okay with the damage so far, right? So securing machine and service identities, you know, service identities, how long are service identities valid for in your organization? Are they 12 months? Do we review them? Who has access to them? You know, even API, you know, you create an API and you give them 12 months access, and then what happens? Somebody else got the key, you know? So it's managing all of that and on what level of access. Secret management, we talked about the credentials, right? How are you managing all your secrets? Are you vaulting them? You know, and who has access to the vault? You know, is there MFA? And enforcing least privileged and continuous monitoring, right? So best practices for developers, avoid hard-coded secrets, right? Embed identity-first controls in apps and APIs. There's a lot of automation in our CI/CD platform pipeline. You know, how are we adding into it really secure practices? And you know, I think we got to look at: do you have a great secrets management platform as well? Because we can be manual, we can put it somewhere, but if that's compromised, then you know you got to be careful about not being on the newspaper, right? I guess, you know, the things to think about is identity-first access. It is not about accessing networks anymore. Identities, and when I say identity, it's human, non-human, machine, agentic AI. Least privilege policies, all of those uses, all of those identities, it may be a little bit repetitive, but, you know, and secure APIs with OAuth or JWT, short-lived tokens and Vault, and continuous validation. Just because you've set it up once doesn't mean it's done. It needs continuous validation as well. So in summary, Zero Trust is a framework, not a product. Like I said, you know, Google the term exists since late 90s. It's a framework and it applies to different parts of technology in an organization. How do we as developers, wherever we're working in, how do we bring that security first mindset? And identity is the true perimeter. You know, organizations should think about strengthening their identity security, and I think developers, the developer community actually enable Zero Trust architectures. So thank you. That was all I had. Thank you. And I have to say, you know, I'm not a software coder, so I'm always nervous when I come and speak with developers community. But I do want to share what I know, and you know, and that's why this quote from Audre Lorde really speaks to me, right? When I dare to be powerful, to use my strength in the service of my vision, then it becomes less and less important whether I'm afraid, because I was afraid coming in. So thank you for being an awesome audience. Appreciate it.
Well, thank you so much, Barsha, for such an insightful session. We really enjoyed it. There's a lot of things that we need to know. I would like to open the floor for the questions. That you have a lot of hands. We'll take a couple of them.
Yep.
I think yeah.
Thank you. It was an amazing presentation. My name is Valentina. I'm also not a software developer, but I do have to do with software development and with SaaS a lot. And I would like to ask a question that has to do with the disaster recovery plans. So given that Zero Trust is a framework, and given that sometimes when identity is compromised, like let's say, just a simple example, we have a huge customer, like I'm contracting, I want a customer, and for them, disaster recovery plans is a necessity to have in place, because once the network or the software is compromised, it sometimes comes to minimize the impact rather than try to avoid it. In this perspective, what comes on the first place in the picture is like how we would deal with storing and accessing disaster recovery plans, given that the identity of a person who actually is under suspicious to be compromised has access to those DRPs. Like, what would the best practice say? Is it better to distinguish those accesses once the person is compromised? Is it better to have another layer of security? Like, what your experience says about this, and what would be your advice in how to deal with that?
Thank you. Great question. Thank you. Yeah, there's a couple of things in that, right? You talked about identity. How do we differentiate if that person's login has created that issue? How do you make sure you don't have access to the backup and stuff? I think there's so many things we can do from an identity point of view in terms of added level of controls when it goes to backup. You know, and I'm just giving an example here. Does the same admin who works on the primary also has the same access to backup? Maybe not. You create a different team or you create a different group. So that's, I think there's a few different things from an identity point of view that you can do that. And then, MFA, like, if somebody wants to go to backup, does it need an approval from 2 other people before they actually touch it? There's got to be a very, very stringent layered security approach before you actually get to the backup, right? And I think if I heard correctly, also, how do we work on the backup as well? I guess storing, you mentioned, yeah. My time from NetApp, right, we were in storage. So there's a rule called 3-2-1, right? Yeah. With your backup data, you got to have 3 sets of data in at least 2 different mediums with 1 as off premises, right? So that's the data disaster recovery system, and backup goes in that 3-2-1 sort of formula. So there's that identity question, I think there's a level of added security, and then the data, yeah, but it's interesting, right? If somebody's data is leaked, it's very likely they're hanging around in the dark web, and so I guess making people, I think users are generally the weakest link. So, educating people, making sure that they understand the risk and stuff, I think that's very, very important. And then you got to have the backup sort of strategy as well. Did I answer your question?
Yeah.
Thank you. I think he had a question.
Thank you very much for the presentation. It was quite good. Zero trust, it's still a lot of ambiguity and a lot of questions going around. So I've got a few questions.
I think the mic is not on. Sorry to cut you.
I thought, okay.
Yes, better.
So I've got a few questions, but I'll keep it to 2. One, if you can clarify, so in one of your slides, you had trust, but verify.
Yeah.
And we are moving towards never trust, always verify. There are verify in both the stages.
Yep.
What's the difference? You are still verifying even with the trust.
Yeah, the inherent trust is the difference, right? So, in the previous world, like if you're, this also from, how Google has so many offices everywhere, right? So if somebody came in and connected to the LAN, they're already trusted. You still have to verify the user and the password, and because there's still role-based sort of access, right? So you still have to verify. But as soon as you're in the network, remember, I don't know if you remember olden days where you had network drives, and you had access to that straight away. That's the level of trust. Whereas now, you're not trusted. You are first verified, and then you're only allowed the level of control that you're given at that point in time. So if you would have the same level of access if you were working remotely versus in the office. Whereas in the past, I remember if we were in the office, we had more access from the same device versus when I went home. Whereas now, it doesn't matter where you are. You're not trusted. Even if you're in the network, you're not trusted. And then you're only applied, the right kind of access policy is applied to you as a user, as an identity. Does that answer?
Sort of. See, I got the first part,
Yeah.
but the verify part, because
Yeah.
it's still verifying. So
Yeah.
what exactly you meant is what I wanted to do, but that's fine.
Yeah.
The second question is, you were mentioning about, and it's good, you touched about the developers, right?
Yeah.
But developers are not the real custodians of the data or the organization,
No.
right? Mm-hmm. It is mainly the architects or the stewards of the data.
Yeah.
Now, you rightly mentioned that developers touch all the 5 pillars.
Yeah.
Now, there have been, I run a consulting company, and
Yeah.
I talk to a lot of organizations, and especially when we talk to the developers, there is a lot of push when we say, hey, zero trust principle is what we are going to implement. Even the developers are not going to be trusted. So, what is your view as a representative of a security company? Because developers, they always want the access to the data,
Yeah.
right? Because they are the internal sort of custodians working on the data, even for data engineers working on the data pipelines. They want the access to the production data
Yeah.
to troubleshoot or work.
Yeah.
However, this whole new concept of trust no one and always verify
Yeah.
basically means even the developers or even the internal engineers don't have access to the internal data.
Yeah.
They get the PAM or privileged access management just for that. So what's your view on that?
Yeah, I think you've actually answered your own question, but I will probably add a little bit to that. I mean, privileged access management, right? Developers would, even though they might not be the custodians of data, they need access to data because everything they do revolves around the data, right? Whether they're creating logic, whether they're doing something to the data, adding logic to the data. So I think that privileged access, who gets access to what data at what point? Just because you're an admin doesn't mean you have access to the production data all the time. You've got a window, Monday, 2 p.m. to 4 p.m., you're working on it. And, next day it might be your mate, right? So I think that, and also, especially with the privileged accesses, it's continuous monitoring, right? If you're accessing the data and you're manipulating it, it's being recorded because if something goes wrong, they got to fall back. Not necessarily to point a finger at you, but really to be able to see what's been done. And so I think. So you asked me about my thought around the privileged accesses and should developers have access to data all the time. I think they should not have access to data all the time. It should be role-based plus what is the need to be working with that data for that point in time.
So what I really wanted to understand is the trust. So I'll probably give you an example. So if there is a Google network, right?
Yeah.
But there are two different organizations,
Yes.
and data is being moved from one organization to another organization as part of a demerger
Yes.
or move or anything. However, the network is same.
Yeah.
Now, where is the thin line where you say, hey, no, we trust the network enough?
Identity. So whoever your identity provider is, it could be Google IDP, it could be CyberArk, it could be Azure ID, Entra ID, and so that is where you would manage that for that period of time or for that project.
Okay.
Add a little bit to that also because I have heard troubleshooting how we managed when we were in a situation like this. Sorry, just some real case. So we've been working with this insurance company, and we also faced the situation that there was a trouble. So our developers needed access to this specific, I will not be disclosing what it was, but we needed those specific files that actually caused the trouble in the system. However, those files contained sensitive data. What we had to do, and those sensitive data was it was agreed that it's going to be only between us and our customer, but it had to do with personal data of people who were customers of this insurance company. So what we actually did, we asked our client, the insurance companies, to send us a set of an alike data that our developers could troubleshoot, having this analyte data, but not related to individuals. This is how we manage that. It, of course, kind of more time consuming, but with that approach, you can actually make sure that if anything is compromised, it's not going to lead to consequences. So in our case, it was this was the resolution which thankfully worked. Yeah. Sorry for stepping in.
That was good? Awesome, thank you. I guess I'll just hand the gifts before.